Hi everybody. We are starting chapter 2, which is on transformations, and I believe I already in my intro video spoke to you a little bit about how transformations is going to be the theme of Pre-Calculus 12, and that's the reason we're starting with chapter 2 instead of with chapter 1. I think that this sets up the stage nicely for what we're doing with all of the other chapters. Because transformations has to do with change, and basically in every single chapter we're going to be doing the same thing. We're going to be changing different functions in each chapter. So this is sort of a nice place to start things off because it sets up the foundation for the whole course. So we're going to start off with 2.1 functions and relations. A lot of this might feel like review to you, which is a nice way to start things off. And so we'll just go through what is a fairly brief first lesson, and then we'll see how that works out. So, functions and relations. Relations are a set of ordered pairs which you're familiar with. We usually write them in the form x, comma, y. It's always written alphabetically, and you know that that also corresponds to our x-axis and our y-axis when we go to our graphing grids or our coordinate plane. And then just a reminder that when we're looking at domain, well, domain would be referring to the x values down here. And when we're talking about range, just to review, are the y values in any equation. So when looking at the domain and range in any equation, look at the restrictions in the given equation. This also you'll see as a theme throughout the whole course. The first thing that you want to look at in your equation is if there are any restrictions, because that's going to help guide us with what we're working with and how to graph it out if that is something that we're going to be doing. So, a couple of things to watch for when I talk about restrictions. So, restrictions right there is the first one is that even roots should not have a negative under the root sign. So, if we take a look at this, our first example here, this square root of x, which you are familiar with, we're going to do a whole chapter on this again this year, radical functions. We know that here, if I wanted to talk about my restrictions or give some more details on this, we would have to say that x must be greater than or equal to 0, because if, for example, we had something like, maybe don't copy this down, but let's say we had like the square root of -4, you can't take the square root of a negative, so that is an imaginary number, and that's why I've put this restriction here where it says x must be greater than or equal to 0. The next one says no 0 in the denominator, so take a look here. It says example is our basic rational function. Again, you'll be doing radical and rational functions all together in the same chapter, and you've done this before, but this in a rational function in its most basic form is 1 over x, and we don't want a 0 in the denominator ever, so I can make the thing at the bottom way more complex than just an x, but for now we'll start with the basics. It's a good place to start things off, and we know that x is not allowed to be equal to 0. So there's some nice basic review to start off with, and then we will get into some more what will feel like review, but it may not feel like review because it's been quite a while. So we'll refresh your memory and sort of get into some of this. So in this first example, it says draw x equals y squared. Okay, I'm going to pull this up so that you can see all of this pretty clearly, and then I'll get to the other example there. But I am just quickly going to sketch this out. There's my x-axis, there's my y-axis, and you can do a table of values if you want to. Pick some values, plug them in to figure out what this looks like. I won't do this very often, but I am going to right now. I'm going to assume you all know how to do this. This is just what you're used to is y equals x squared, which is a basic parabola that you did for months and months on end last year. But this one is the flip of that. It says x equals y squared. So we know that it's actually a parabola that is open sideways because it's the x that's isolated and not the y. So this is what it looks like. And it says draw this out, so we've done that, and determine the domain and range. Okay, domain, again, from what I did up above in green, domain is referring to the x value. So we would start at the smallest x value. So we're looking left to right. The smallest x value is at 0. So I would say my domain is x's. It can be equal to 0 because you can see it is right there on the graph. So I would say x is greater than or equal to 0. So there's the first one. And then when I'm looking at the range, which was this part here, we're looking at the y value. So these arrows at the top and the bottom indicate, I'm going to get rid of this green arrow because I'm probably confusing you, but these arrows at the end of the sideways parabola I've drawn would slightly be extending, going in an upward and downward direction. So what I am going to say is that my range would be all real numbers. Okay, so there's a little bit of built-in review. Let's take a look at this one that has a little bit more going on. Y equals 2 minus the square root of 2 minus x. It says determine the domain. So the range for something like this is a little more complex. So we're just looking at the domain. And basically what that means, or what that's saying, is which x values are allowed. And the way to do that, well, we would want to look at the most restrictive part of this equation, which happens to be under here. So if it happens to be under here, well, we know from back here when we first looked at it that, so back here, that we want the portion under the root sign to be greater than or equal to 0. So I can, if I want to talk about my domain, I can basically take what's under the root sign here, and I can set that whole thing. So I know the root of 2 minus x has to be greater than or equal to 0. So basically, I'm trying to work my way through this to solve and isolate to figure out what x has to be. And this is just practicing or brushing up on our algebra skills. Algebra is all about opposites. You've been hearing me say that for years, but we would basically be squaring both sides to get rid of that. So we're just dealing with 2 minus x is greater than or equal to 0. And there's a couple of ways we could go about the next step, but we had like, 5 months off school, and it's been a long time, and maybe we need to take baby steps and go slowly because it's been a long time, possibly, since you've done math. So the next thing we could do is get rid of this 2 by subtracting it on both sides. So I could, you don't have to write down every single step, but I want to make sure you all get where this is coming from. But we could say minus x is greater than or equal to, and this time it's 0 minus 2 is just negative 2. We don't want a negative here. We want to make it positive. So I would divide this by negative 1 and divide this by negative 1. So that's gone. But just a reminder, because it's been a while, that when we divide by a negative, it actually flips our sign over. So instead of it being x is greater than, it flips to make it less than or equal to, and it becomes positive 2. So after all that, this is what our domain would be. And you don't need to be unsure about this. You can actually test this out. So what we're ultimately trying to do is figure out if this is true by plugging in, like if we're saying x is less than or equal to 2, we could pick something like x equals 1, because that satisfies this rule here. And I could plug it into my equation to see, does it allow me to take the square root of what's under there? So if I plugged in 1, it'd be the square root of 2 minus 1. So it would work, and therefore I know that I have the right solution here. X is less than or equal to 2. Okay, moving on. We have something called a one-to-one function. You saw this for the first time, maybe the only time, in grade 10. It's been a long time. So let's brush up on this. Each input or x value has only one output or y value. How we can test this is to do the vertical line test. I like to abbreviate this because we're going to see it come up over and over again. Or the horizontal, and the horizontal line test. So we've got to do both of them in order to figure out if it's a one-to-one function or not. So when I look at a graph like this, I want to figure out if this is a one-to-one function or not. So, well, basically what I'm trying to do is look to see if there's any overlap. Vertical line test would be if I drew a vertical line, is there anywhere on here that it would overlap? So it looks like here could potentially, but if we look at it, notice how there's a colored in circle there at x equals -2 and a hollow one at x equals -2. So technically at this pink vertical line, it doesn't actually cross. So it does actually cross the pass the vertical line test at every point on this graph. So yeah, it matches that. But if I were to go and do a horizontal line test across here, I don't even have to actually do it. I can tell right here, there's a problem. That's an actual section of a horizontal line. It doesn't pass this. So this is not, I should say it down here, this is not a 1-to-1 function. So that's a bit of review because it's been a while on what this stuff means. And then if I wanted to go to talk about the domain of this thing, well, it's a good habit to start from left to right. So if I'm talking about domain here, I'd want to start at x equals -1, 2, 3. So -3 is my smallest x value. It's not actually equal to -3 because notice there's a hollow circle. So I'm going to say it's greater than -3. And it's x I'm talking about. And then take a look here. Although at -2, there is a spot, there's a gap, but then the rest of the graph actually continues right until this point, which is at x equals 0. So I could say x is less than or equal to 0, because at 0, that dot is colored in. I've purposely chosen a really nitpicky one to refresh your memory, because that means the easier ones you'll be able to do on your own. But a weird one like this with so many things going on, it's probably helpful if we go through it together. So we're not quite done though. There's more going on here. If you take a look here, I'm going to put a little comma there to carry on to the next part. Notice how at this x value of 1, x is greater than 1, but not equal to, because it's an open circle, and then less than or equal to 4. So yeah, it's interesting because there's a couple of different sections, or it's broken up into different pieces, but it's ultimately, it is all on one graph, and it's showing you a whole bunch of things going on all at once. We are going to do the same thing, but with the range or the y values. But these ones are a little bit more interesting. This time y is actually equal to, because it doesn't go from a smaller y value to a larger one and connects like on an angle. They're actually chunks of horizontal lines. So in this case, I could say, and I like to always go smallest to largest. It's just a good habit to get into. So y equals -1, comma, and y can also be equal to 1, and that's talking about that part there. So y equals -1 would be that part there. Y equals 1 is that part there. And then the last one would be up here, which is at y equals 1, 2, 3. So y equals 3. Might have been nicer if I color-coded all of them, so let me go back and do that now. Y equals 1 was this one. So you can very clearly see which portions we are referring to. Okay, so moving along, we have a bit of a review of a diagram that I could have made nicer, but that's okay, it gets the job done, that you may or may not remember, and it may have been a rectangle instead of an oval shape like this, but basically when we're looking at functions and relations, there's 3 different names that we could give them, or 3 different categories that we could put them in. We talked about one-to-one function. That is if it passes the vertical line test and the horizontal line test. And then if it doesn't pass that, I would call it a function. If it only passes the vertical line test, it's a function. But if it doesn't even pass the vertical line test in the first step, it would be a relation. So an example of that is the sideways parabola that we drew. If you look at this, if I were to do a vertical line, you don't physically have to actually do it. You can tell just by looking at it, but just so you can clearly see, if I were to draw a vertical line, it would actually cross at these 2 points. Because of that, I would classify this, I would classify this parabola as a relation. And if I had a normal parabola, not to say that that's not normal, but you know what I mean. So if I look at the function, that could be just a regular parabola because look, it's going to pass the vertical line test everywhere on there, but it's not going to pass the horizontal line test. And if I want to give an example of what would count as a one-to-one function, well, if I just had a line like this, it passes the vertical line test, passes the horizontal line test, so that's what it would look like. So hopefully that little explanation helps bring some clarity to this. And you can do the work from 2.1 for this. And I'll have another video posted shortly for 2.2 coming up.